Hello everybody, and welcome to this project of Trigonometry and Introduction to Statistics. Our team consists of Aida, Miguel, Sebastián, and your server, Ricardo. It is our pleasure to present you problem number 5.
Problem number 5 consists in a mass attached to a spring moving up and down in a harmonic motion. The graph right here expresses its displacement, d of t, from its equilibrium at time t.
To solve this problem, first we need to find its amplitude. But what is the amplitude? The amplitude of a wave is the distance between the equilibrium or rest point right here and the crest or true position. The crest is on the top part and the true is on the lowest part. In the problem number 5, the amplitude is 5. We take in consideration the distance between the equilibrium and the crest. We can see that there are 5 units here.
So what is frequency? Frequency is the amount of cycles that are completed in a specific amount of time. The way to find the frequency is with the formula 1 over the period, which is shown right here. And now, what is the period? The period is the time that takes a complete cycle of vibration to pass at a given place. The formula of the period is 1 over the frequency, which you can see it over here. So in this graph right here, you can see that the frequency is represented in green and the period is represented in orange. By using the formulas that were explained before, the period of this graph is 2 over 5. And the frequency is 5 over 2. One thing to make emphasis on is that you're always going to have either the period or the frequency. Now we're going to explain how to find the displacement.
So now we're going to work with the original formula of the problem. So problem number 5 gives us the determination of finding the displacement of a certain sign, a function sign. So in order to do that, we're going to have this basic formula over here, which is d of t equals a times the sine of the w times the time. Okay, so what is w basically? Basically, w equals 2 times p times the frequency, and that is how we are going to obtain it. So if we substitute the values in the original formula, we get that d of t equals a times the sine of 2p times the frequency of time. Basically, after substituting the value of the frequency, we get d of t equals 5, which is the amplitude, times the sine of 2p times 5 halves of the frequency, and then we're going to multiply that times 4/5, which is equal to the time in our graph. Now, after that, we can substitute this value and transform it into a decimal place, and we're going to have d of t equals 5 times the sine of 5p, which is basically equal to this multiplication over here, and we're going to have the 0.8, which is basically 4/5. Now, once we have that, we can all place it in our calculator, and we're going to have this result, which is 1.0.
As you can see, we used every concept that we explained before. We used the frequency, the period, and we use the formula that appears right here. First, we needed to look at the graph to obtain these values, and at the end, we had the result that we noted. This is how we found the result for our problem, that was to find the displacement of our mass that is on a spring and is in simple harmonic motion.
By solving problem number 5, we get a new formula. d of t equals a sine times w times t. We know with this formula that we can apply the trigonometric functions in our daily lives, as we can